Hey everybody, today I want to go through properties of quadratic functions. This is a topic that we have discussed up until this point, but it was really like an introductory thing for us before. It was trying to tie everything together, but just try to give us a sense of how much we really knew about our parabolas. Well, now we're at a different stage. We've examined our parabolas in greater detail. And now it's time to kind of set that expectation level. This is about us getting really good at identifying our key properties. So let's jump in. I want to tackle this from kind of two standpoints, two perspectives, two angles. I want us to be able to address our properties of our parabolas when we have the picture, a graph or a sketch of our function. And then I want us to be able to deal with the properties when we don't, when we just have an equation. So let's take a look at the first one. You can see it on your screen right now. You have a picture of the parabola, but you also have down below the equation for it. So we have the combination of the two. What I would like you to do is to go through as quick as you can and try to fill in all of those missing properties. Having the picture and the equation should be extremely helpful. I want you to try it on your own. Pause the video, and then we'll come back and we'll see how we match up. Okay? Pause it now. Okay, we're back. So, a couple of the things that I would like to go through. Right now, I'm just going to uncircle that equation. I'm going to deal with this kind of twofold. I'm going to go through and I'm going to address all of those properties from the picture in purple, in red to match the graph. And then I'm going to deal with the equation stuff in purple. There's certain times to trust your eyes, certain times not to, and I want us to make sure that we're comfortable with both. So I would hope that us looking at the picture itself, we would have been fine to say that that parabola is opening up. We could have located, because we have a grid and we can see the scale on both axes, that our vertex should have been at -3, -4. You can tell your shape. Now, see, this one is tough to be able to tell the shape on the picture. So I would probably revert down in purple to my equation where I can see I have an A value of 1. That means I have my normal shape. Now, I said it was more difficult. I didn't say impossible. You take a peek at that graph and you will notice it follows our normal shape. To the right one, I go up 1. I have a point on my parabola. And then when I go to the right one again, now I go up 3. I am fitting my normal shape with my step method. So I could tell based on the picture that I had a normal shape parabola. However, I hope that's more obvious in the purple with the equation. Okay, I take a look at my axis of symmetry. Well, that should be an x equals -3. Make sure you don't write down -3. That's a value. Axis of symmetry is a line. Make sure you give me the equation of the line. We should have been pretty comfortable to be able to go through and tell me that that parabola has a minimum because I can see the bottom. The minimum value is -4, the value of my function at my vertex. My y-intercept. Well, if I go up onto my picture, I can see that my y-intercept, that looks like it's at 5. It looks like it's at 5. But maybe it's a little off from 5. So here's where I want to go through and I want to highlight a couple things. Trust your eyes, but don't completely trust your eyes. Notice, if I had to go back and get rid of my vertex, I would have preferred to use my equation for my vertex, because I can see the vertex in my equation. I know it there. I was estimating it there. Okay, same thing when it comes to y-intercepts. Look up where I circled that green. I don't know if that's exactly at 5, But I do know that I can find a y-intercept by allowing my x to equal 0. So when I make that substitution, I'm going to get 0 plus 3, which is 3 squared. That's a 9. And when I subtract 4, I now know it's exactly 5. I know that my y-intercept is correct at 5. Do not write down y equals 5. Don't. That is a line that is incorrect. I'm also going to argue to you, please don't write down 0, 5. Yes, that is the coordinates of my y-intercept, but it's redundant. When I ask you for the y-intercept, that implies your x value is 0. Don't repeat it. Your y-intercept is 5. Just write down 5. Okay, same thing when it comes to our x-intercepts. Like it looks like I'm passing at -1 and -5, but I don't know for sure. So what I could do is I could find my x-intercept by allowing my y to equal 0, and now I get this equation. Remember back to our Unit 3. Don't expand your brackets. Your x is in one spot right now. Like it's right there. You expand it, you're going to put it in multiple spots. Now you have to factor or formula. Don't. Isolate. I can get rid of my 4. Now I can get rid of my squared. Every time I take the square root, I get 2 answers. Now I can isolate my x. Calculate those two values, or I should say simplify them. -3 plus 2 is -1, and -3 minus 2 is -5. There we go, -1 or -5, and those are my x-intercepts. I shouldn't even write an or in there. That's an and. They both are. -1 and 5. Okay, I'm hoping that that was pretty comfortable as we went through, and we were feeling pretty solid about it. I'm hoping I also gave an example of how you can bounce back and forth and use the picture and the equation to both come together and agree with each other. I use them both as a check. Okay, I think this gives us an opportunity to try another one. There is another graph of a parabola for us, and I want you to do the same thing. I want you to go ahead and complete all of those properties for that parabola. Okay, try it on your own. Pause it now. Okay, we're back. I don't think I need to use colors for us. We can see the picture. We can see the equation. I'm just going to go through and answer all those properties and discuss where I got them from. If I'm going to go through and figure out direction of opening, I'm going to use my picture. That's pretty obvious. It's opening down. My vertex is actually labeled on my diagram, so I can see that that's at 227. The shape. Well, the shape, I'm definitely going down to look at my equation. I can see that I have an a value bigger than 1, at least the absolute value of it is, so I know that I have a steeper parabola. My slope is steeper for that one than normal. My axis of symmetry is my vertical line through the vertex. I can see that that parabola has a max because it has a top, and its maximum value is 27. My y-intercept, well, I really love the fact that my y-intercept has been labeled. You can see my point. It is labeled at 0, 15. So I know that my y-intercept is 15. And I really love that I can see both of my x-intercepts labeled. There they are at -1 and 5. Okay, I am hoping that that was a nice soft landing for us going through and finding our properties. Okay, if we have a picture, I'm hoping it's pretty straightforward. Now, what if we don't? So, what you see on the page now or on your screen, there is the same thing we've been doing so far today, except I took away the picture. So I can't simply read some of my properties. Okay, what I want you to do is to try to work your way through again and come up with all of those properties. You'll notice I've added in some domain and range for the equation given. Okay, try it on your own. We'll match up in the end. Pause it now. Okay, we're back. So, like we did in an earlier lesson, I'm going to go through and I'm going to try to deal with some colors on this one. I'm going to break it down into 3 colors this time because I think we can really nail down the parts. I'm going to look at the effect of the negative and what that negative tells me. I'm also going to take a look at the 2, what the 2 tells me. And then because these are so connected, I don't need to look at my horizontal shift and my vertical shift separately. I'm going to look at that 3 and that 4 together and what that tells me. Okay, I'm going to take them in their colors. Obviously, you don't have to do it this way, but I think it can help you to see where I'm gathering all my information from. Okay, I'm going to go and start off with the red to begin with. Everything I know on the red, well, that negative A value tells me that my direction of opening is down. My parabola is decreasing to the right. It doesn't tell me anything about a vertex or an axis of symmetry, but since it's opening down, it does tell me that I have a max. I don't know what the maximum value is from the red. I don't know the domain from the red, but I do know something about the range. Because my parabola is opening down, I know I have y is less than or equal to something. I don't know to what, but I at least know it's less than or equal to. And I don't know anything about the y-intercept, x-intercept, or shape. Okay, everything from the negative is what you see listed in red. Now, let's progress our way through. If I go to the blue, what does the blue tell me? Well, it doesn't give me anything about the vertex, nothing about the axis of symmetry, nothing about the max-min value, nothing about domain, nothing about y-intercept, nothing, but it does tell me shape. Because that value that I circled in blue is bigger than 1, then it tells me I have my steeper parabola. Okay, that's all the blue gives me. That wasn't much. Now, let me fill in everything based on the orange. My orange is going to tell me my vertex. Shifted to the right 3, down 4. Because I know my vertex, then I know my axis of symmetry. I know my maximum value. It doesn't tell me anything about the domain, nor the y-intercept or the x-intercept, but it gives me those 3. Okay, I want to go through and I want to fill in the rest. Well, pretty quickly. My domain is always the same thing. X can be anything within a parabola, so I don't gain anything by looking at the particulars of the equation. My y-intercept and my x-intercept, that's going to require a little bit of work. And for that, I want to go through and I want to erase all my colors in the equation. I just don't want us to get lost with all those things circled. I'm going to do all my work in purple. So, for me to find my y-intercept, I know my x has to equal 0. That means I can square my negative 3, which is 9. I can calculate that, and I can simplify to negative 22. So, there is my y-intercept. I can put that in my list of properties. Okay, I also need to find my x-intercepts. So I'm going to shrink it down a little bit and just move that to the side. This may take a little more work. It normally does. That means my y is going to equal 0. When I sub that in, I now have this equation. Like I said previously, don't expand. Don't. But I also want to show you a little bit of a quick trick. I already know before I do any of that purple work, any of it, that my answer is no x-intercepts. Now, I wouldn't really write no x-intercepts. Since the question asked me for what are the x-intercepts, my answer is there are none. Now, you may look at that and you may go like, okay, how can you tell? I want to go through the purple so you can first see algebraically why there are not. And then I want to go through very quickly the reasoning I use to be able to state that. Take a look up at my purple equation. If I now go to isolate for x, I have to get rid of my minus 4, which means I'm going to add 4. Now I need to divide out that negative 2. And for a number of reasons, you should be able to see that that equation has no solution. Like, let's take the most obvious. Look at what you have on the right side. You have a perfect square. And somehow when you square that, it gives you a negative? Okay, we know that that can never be the case, so you have no solution. Okay, what else could I have? Well, if you ended up wanting to get rid of that squared, then you would take the square root. And when you try to take the square root of a negative number, that's undefined, so again, no solution. I'm hoping that we can see either of those reasonings within that equation. And because I have no solution when I'm looking for my x-intercepts, that means I have none. Okay, now I want to back up. Because, as I mentioned, I don't ever need to do that. I'm going to put on a quick sketch, and this is something that you should always be thinking of. When you go to find your x-intercepts, we need to recognize it takes work. And I actually want you to be motivated to avoid the work. And so if we consider something that we learned earlier on in the unit, the location of the vertex and the direction of opening. Well, if I go and put on my vertex, which was at 3, -4, let's say it's there, and now I examine my direction of opening, I'm opening down, we should be good to see, without any other details on that picture, that that parabola is never going to hit the x-axis. So I can tell just between vertex and direction of opening whether I even need to look for x-intercepts. So the other instance that could have happened, what happens if we have our vertex above the x-axis and we're opening up? Same thing. So can we just imagine in this problem that you had your vertex exactly where it was, but then we knew that the parabola was opening up? Okay, clearly that parabola is going to intersect the x-axis. It's going to cross it. So then I decide to go and do my work. Okay, seriously, it is worth the 5 seconds consideration to save you all that time. Okay, nice. I'm going to get rid of some of that little sloppy stuff that I wrote down here. I can get rid of all that stuff. And there are our properties. I'm hoping we matched up. I'm hoping that that went well. Oh my gosh, I noticed I didn't even plug in my last. Look at my range. I forgot to fill it in. My range has to be y is less than -4, and I'll keep it in the orange, and there we're good. Oh, thank goodness. Okay, let's jump in for another one now. Okay, what you see in problem B, there is another parabola, and I want you to go ahead and come up with those properties. Okay, pause the video now. Okay, we're back. I don't know. I'm going to do the same thing as what we did before. I'll address that, and that's all in my colors. But just so you don't think that I had to go left to right, I'll go backwards. I'm going to find my orange first, just for a little variety. So based on that, I can see that my vertex would have to be shifted left 3, up 4. Hopefully we match up, because as soon as we know our vertex, then all of those other things fall in line. I know my max-min value is 4. I'm going to fill in my domain right now because I already know that. But I don't know anything else based on it. So that at least gives me that. Based on my blue, direction of opening, no. I work my way all the way down. I at least know that my parabola is going to be flatter than normal. I've got my blue value. That's a value less than 1. There we go. My negative is going to tell me opens down. That tells me I have a max. And it also tells me that my range has to be y is less than or equal to. And there is my range part again. Let me make sure I fill that in orange. That my range has got to be less than or equal to 4. I could have filled that in previously based on my vertex. Okay, I've got a little bit of work to do. I'm going to get rid of all those circled properties again. And time for me to find my intercepts. So to find my y-intercept, my x value is 0. That gives me my negative 2/3 times 9. I love that because now I can see that I cross-reduce. There is my negative 6 plus 4, negative 2. Nice. Okay, before I go to look for my x-intercepts, I start to picture my graph. My vertex is up here, opening down. Yes, my parabola should cross the x-axis, so I'm algebraically going to find it. Let's say I make some silly mistake in my process that would have given me, I don't know, a negative underneath the root. Then I know I've goofed up somewhere because I should be expecting to get some answers to this. So there is me blindly copying out my equation with my y value equal to 0. Okay, now I'm going to start getting some stuff start to isolate my x, which means I'm going to start getting some stuff to the other side. First thing I can do is get rid of my 4, and I'm going to take this slow and methodical. Multiply out my 3. Divide out my 2. I think I would have a lot of you that with practice could skip over all those steps, just as we did in our previous unit. Okay, comes in, I can take the square root. And now I can isolate, so get rid of a plus 3. I am going to minus 3, and there are my 2 roots. Notice, had you expanded your brackets at the very beginning, you would have been stuck using quadratic formula, and it would have reduced. You would have had a lot of work to do. Hopefully that isolating then was very efficient for you. And all you have to do is write the plus or minus in there. Don't ever feel like you have to separate those into 2 distinct roots. No, that is good form. Okay, hopefully we matched up, and hopefully we're getting efficient with what we're doing. So I want to leave you with one last problem to work through, and we'll use this one as our sum up for the day. Okay, you can see your last one on the screen. I want you to be able to work your way through it on your own. We'll match up in the end. Let's pause the video now. Okay, we're back. So, you will notice one key thing on this last equation. I didn't give it to you in vertex form. I gave it to you in standard form. Ugh, it's not as useful. That means we're going to have to do some work. So, I'm going to take you through, similar to what we did before, what can I read from my equation? And you'll notice I still have my a value here. That is a positive value, which tells me that my direction of opening is up. It tells me that I have a minimum. Because it's a 2, I could go even further and say steeper. But as I examine everything else about that, my range, I guess, that's the one I always end up forgetting when I do it in its parts. I at least know y is greater than or equal to. There's everything I know based on the 2. Okay, I don't know my vertex. That's going to require some work. But at least the nice part is that minus 5 on the end, I know that that's my y-intercept. So that I don't have to do any work for. So I got to save a little bit, even though I don't really like that trade-off. Okay, what I now have to do is go on the hunt for a bunch of things. I need my vertex. I need my x-intercepts. The only thing that I don't have to worry about, my domain, because I know that x can always be anything. So I am going to go on the hunt for my vertex and my x-intercepts. The first thing I might do is take a look and see, does that factor? So when I have my 2 and 1 and my 5 and 1, I can get a 10 and 11. Okay, that is not going to factor. So I am going to use quadratic formula. Now, you'll notice that I look to see whether that factored first before I even considered looking for my vertex. Let's say that I did my vertex first. I could then say, okay, for my minimum, I know that my x is going to equal negative b, so the negative of negative 12 all over 2a. I can see that I've got an x value of 3 at my vertex. I can then sub in my x equals 3, and that was the process that we used to change to vertex form. You'll notice nowhere in this problem does it ask you to change it to vertex form. So you may end up going through and dealing with that, then finding your x-intercepts, which means let your y equal to 0, and I'm just going to argue you're maybe duplicating some work. So, what happens if I deal with it the opposite way? Well, if I'm going to find my x-intercept, my y equals 0, and because it didn't factor, I know I'm going to have to use quadratic formula. So, x is going to equal negative b plus or minus the square root of b squared minus 4 times 2 is 8 times negative 5. Be very careful. So that's a positive 40 all over 4. That is going to equal 12 plus or minus the root of 184 over 4. Okay, you are now going to take that 184 and look and see whether we can reduce that. Well, on a quick calculation, if I sub 4 in, 18 divided by 4 is 4 whole times with 2 left over. 24 divides by 6, so that worked out nice. It doesn't take me any farther because that's 2 times 23, and neither of those can factor further. Neither of those are perfect squares. So when I reduce this, I'm going to get 12 plus or minus 2 root 46 all over 4, of which I can now reduce that, divide everything, all my whole numbers, by 2, because they all share their common factor of 2, and I can shrink that down to 6 plus or minus root 46 all over 2. Okay, dealing with it in that order, if you recall, quadratic formula also tells me my negative b over 2a. It tells me the x value of my vertex. Whether you want to use it right away as the 12 divided by 4, or whether you want to use the reduced version of that, 6 divided by 2, it doesn't matter. If you recall from earlier, we knew that the vertex X value was 3. So I could sub X equals 3 right now back into my original. I get my confirmation when I simplify. My second term is double my first, or my first is half the second. Opposite signs. So when I go through and simplify that, I think I just found my vertex faster. So maybe you can see why I first looked to see whether I was going to use quadratic formula or not. If I need to use quadratic formula to find my x-intercepts, why not just use it to find the x value of my vertex as well? Okay, I have everything I need on my page. It's now just a matter of me plugging everything in. So my vertex was at 3, negative 23. If I do a quick check, my vertex is below the x-axis. It's opening up, so I should get x-intercepts. I found those x-intercepts to be 6, and I'm about to write that really big. 6 plus or minus root 46 all over 2. Yikes, I did not give much room for that. Okay, I can fill in the rest of my stuff. My max min value is now at negative 23. That's my minimum. And my axis of symmetry was x equals 3. And I almost walked out again without filling in my range being greater than or equal to negative 23. There we go. Okay, maybe something with regards to a little bit of advice. Something that allows us to be a little more efficient with our work on this last one. Okay, I took you through a number of examples today. 2 with pictures, 1, a few more labels than the other, and 3 problems with the equation. 2 in vertex form, 1 in standard, many ways to get there. Your job is to get practice and try to make this as automatic as possible. This is a key component of our course. Let's make sure we get really good at it. Okay? Best of luck.